So that should be starting to stream on YouTube. Taking a while to get there this time though. It's at 60%, now it's at 100%, so we should be live. Okay, so just a reminder, this is being recorded. Feel free to view the live stream on YouTube if you don't like being recorded. And that's where we are. Even though it's October, we've still got quite a way to go. All right. And one of the things, well, there's a few things I wanted to draw your attention to today. But one of the things I wanted to draw your attention to is I want your groups to come up with your own project. And I have a few ideas, and they're sort of a little bit limited by the hardware we've got, and they might be limited by the hardware you have, but it's worthwhile thinking about. Just an example of the sorts of projects that the class did last time I did this course. They did if anybody, you're probably all too young, if anybody remembers the Little Brick Out game, or even going further back, the original Pong game, there was one team that basically did a paddle that you could move backwards and forwards with two of the buttons, and then there was a ball that bounced off a wall, and the aim was to try and move the paddle so that you bounce the ball back against the wall instead of dropping it off. And that was all done on one of the boards we were using before, and this display was generated on a VGA output. And these boards have a VGA output. The issue will be whether you have access to a VGA cable and being able to see the output. But there are others. Another example is there's I've forgotten where it got to. It's probably down there on the floor. There's each of the boards that I'm handing out comes with a remote control, and the board has an IR, an infrared receiver, that you can pick up the signals from that remote control with, and that might be fun to do too. It's a bit more challenging than some of the projects we're doing up until then, but we are going to have, whatever it is, 4 weeks worth of sessions, maybe longer, to get it done. Okay. So what else we got here? So that's just reiterating that. I should have redone this numbering. I think I merged those two labs, right? So we should have been, the testing of the 4-bit adder subtractor is due this evening. We will have some time later on today to work on that, and I want to talk about the next lab, which is a group lab, and we're basically going to go back to lab 3 and look at deploying lab 3 to one of the boards. I've made that due in a couple of weeks' time because there are still some people who can have the board, are not in a group with the board, and I would like to distribute those boards sometime over the next week, if at all possible. Just a reminder, the midterm exam is released. I've noticed lots of people have booked. Thank you very much for that. There's still a few people who haven't booked your sessions. Bear in mind, I've got other classes as well that I'm going to be booking midterm sessions for, so the slots that are available now may not be available over the next week. So I made 466 the earlier side, so I released that booking slot earlier, but the other students are going to be booking their slots shortly. Just a reminder, what I'm going to do is I'm going to ask you about this design problem, and then when I give you some I'll ask you to respond to the questions about that orally, but then I want you to actually do a design. And when I get you to do the design, I'm going to give you a table of A and B. So, right, we might have 0, 0, and C and D might be 1 and 1, and maybe that's 1 and 0, and maybe that's 0 and 1, and maybe that's 1 and 1 again, and maybe that's 0 and 0, maybe that's still 0 and 0, and maybe that's 1 and 0, right? So I'm going to give you values either 0 or 1 for A, B, C, D, E, F, G, H, J, K, L, well, no L, M, N, P, Q, R, and S. I left out I, L, and O just because they look a little bit too much like 1s and 0s. And each of you will be given an individualized table like this, so everybody will get a different set of values to make the counter flip through. And I'm not going to go through the questions. You've had the questions for a while now, so I hope that's all clear. There is a bonus question. If you decide to do it, that's 20 points over and above the, 140 points. So I don't know what that comes out as to a percentage, but it does let you go a little higher. Any questions about any of that so far?
Professor, I have a question. It's kind of excessive. It might be just easier just to write on a pen and scan it, but I do have like a drawing tablet. Would you accept like if I shared my screen and then drew it, like present it to you real time as I was like talking about it?
If that's the way you want to do it, that is perfectly acceptable. It's in no way required, provided you can talk your way through it. And it is a little complicated to talk about, but that's why I'm going to, I'm not, these aren't the only questions I'm going to ask. I reserve the right to ask questions to resolve any ambiguities or anything like that. But certainly being able to present something written may make it easier to get things across. It all depends on exactly how you tackle it. Does that answer the question, Quentin?
Yeah.
Okay.
Thank you.
You're welcome. Okay. It's so nice to be able to hear people for a change. I don't know what I think I know what I did wrong. I'm hoping it's not going to impact the quality of the audio. What I think happened is I had an audio mixer in Streamlabs that was pulling in the desktop audio a bit better, or I thought it was, and because sometimes the desktop audio, that is usually your voices, didn't come through nicely on the recording, and I wanted to make that better, but it seemed it stopped me hearing you for some settings, and I didn't have time to figure out the settings. Okay, I haven't put any new slides in today's slide pack. The reason is because I'm basically going to go through, I'm going to be using the VHDL notes from now on, because I think it's they're all there and I want to mark them up periodically, right? And I think there's everything that we need to know in here. And if I mark them up appropriately, then they'll be available in OneNote. Okay, so what I wanted to talk about today is a couple of variations in the way we could do things, right? And let me just, I'm going to do it with reference to, what did I put there? I'm going to, well, eventually want to get to lab 4, but I'm going to do it with reference to lab 3 initially, okay? So remember, lab 3 was to do a half adder, right? And let me just grab the picture of the half adder that we were using. Sorry, I've got to go back to the labs. Okay, there's the half adder. And all the VHDL code. So well, that didn't do anything, did it? Let's see if we can save image as, and then insert a picture. I'm just getting the truth table, right? And then let me copy that as well. And let's see if I can, oh, where is it? Home. And it's way too small. And let's move that out, and let's, why is that deciding to wrap there? That's pretty atrocious. There we go. Okay, so this is the starter code that I gave you, and remember the thing I didn't do is I didn't actually tell you how to do this, and the aim was to change, to look at the S column here, right? And if you remember your 363, this S column is nothing more than an exclusive OR, right? It's a 1 whenever either B or A is a 1, but not when both are a 1. So this one should be A exclusive OR B, and then C, funnily enough, is just A and B. Jacob, just the screenshot of it compiled correctly. it might be good to put the both the VHD for dog and VHT for Tom files into the as appendices in the report, just so that I can read through the code. But yeah, in the body of the report, just showing that you correctly compiled things, and maybe some screenshots of the simulation would be good. Okay, so there's a way to do it, but there's another way to do it, right? And I thought it might be good to see what that other way is. And let's see if I can look at that other way of doing it. The other way of doing it, and it's going to be in the VHDL notes. No, maybe I've got to open up the actual PowerPoint file. Sorry about this. I should have had it open. Sorry. Right, so maybe I can't do this as directly as I was hoping for. Let's have a look. So what I basically wanted to get through, now I think it's down here. Here we go. Here we go. So what I want to show you is a couple of other methods in VHDL, right? Or a couple of other pieces of VHDL. And I think One of them is a case statement, right? And one of them is the a loop. So let me, sorry, I should have been better prepared for this. And I should have put, it's on page 80. That's on page 47, so it's further down here. There's weights, which we talked about. Variables, which we talked about. Signals, which we talked about. I don't think we've talked about if statements. We could do that. Here we go, case statements. Sorry about that. So this is the format that, where's my drawer? This is the format that a case statement does, right? It can only be used within a process, so that's one thing. And what it lets you do effectively is write out the whole truth table directly, right? And let's just have a look at, I think there's an example here, right? So here is a process. Remember, a process is something that lets us write sequential code in VHDL, and this piece of it is the sensitivity list. And we came across at least the process piece in the test bench, right? There were two processes in the test bench. One was the initialization, and one was the actual test. I don't think any of the test benches used the sensitivity list. And all the sensitivity list does is, if any of these signals in the sensitivity list changes, then the process gets executed. Okay, so here's the process called mux. Here's the case statement that I wanted to talk about now, right? Case select is, when it's 0, then do the A goes to the output. When it's 1, B goes to the output, and otherwise send A to the output. It's probably not necessary, but this is mainly to show the others option. It's like the default in a switch statement, if you know C. Okay, so what does this mean, right? Well, it means that if we can combine our A and B values, then we can effectively just write out the truth table. So let me, before we go there though, this architecture, right, is a 2-to-1 mux. Does anybody remember what a mux is?
A multiplex?
And what's a multiplex?
When you're able to select few inputs and get many.
Well, sort of. So a multiplexer, right, has two inputs, and in this case it's only a 2-input multiplexer, it's a 2 to 1, right? So the output is the mux and the input is the select. And in this case, when select is 0, then, so this is the 0, what happens with the 0, right? When the select is 0, then we do that, and otherwise when the select is 1, we do that. Okay, so that's what a multiplexer does. And that's just a 2-input multiplexer or a 2 to 1 multiplexer. You can have a 4 to 1 multiplexer or an 8 to 1 multiplexer or a 16 to 1 multiplexer. In those higher order ones, then you get more than one select line, right? You have 2, 3 or 4-bit select lines. So that's what it's doing. So let's just go back and see if I can show you how you might use a case statement in our example. Okay, so for a start, we can only use the case statement. Oh, then I gotta go back and do some text for some reason. There's text mode, there we go. Right, so for a start, I need to, I can only use a case statement inside a process. So let's call this process half, and the things that we want to change, that we want to be sensitive to, are the two inputs, A and B. Okay? And then we'll begin, and then we'll end process half. I think that's what the syntax was telling me before. Let me just see if I can bring that up.
Is half the name of the process?
Half is the name of the process, yes. So this is something that I've made up, right? And it's going to be the name of the process. And that's why I've used the same name down here, just to show that that's the end of the process. And I forgot to put a semicolon there. Okay, so what I could try and do, and I don't have it yet, so let me, excuse me. What I could try and do is, if I had A and B together, I could say case AB is, and then I could say when 0, 0, and then I could say, well, when A and B is 0, 0. In fact, let's change this process to be the sum process. Okay, so it's going to set the S column. So then I could just say, if that's true, then I just do that. Okay? And then I can do the same for all the others. Right? And in the two middle ones, then I can do that. So effectively, and I still haven't got what AB is yet. We've got to figure that out. But effectively, a way to do this is to take the truth table that you need to implement and just copy it directly over into a case statement. Now, the question is, how do I get that A and B? And oh, so I think I can just do that, but I'm not sure. So let's go ask a compiler. Right? So the ampersand operator, and it's called the concatenation operator, you can concatenate two objects of the same type. In this case, A and B are both of the same type. They're both of type std logic into an array, right? And I'm wondering whether, because I did that, I need to do that instead, right? Because I think when we work with std logic values, we have to use double quotes. She would do double quotes for me. There we go. Okay, so
Usually the addition sign is used for concatenation. Is it the and for this or not? This amber something sign that you used?
this is the ampersand, and I believe ampersand is used for concatenation. What was the question? Sorry, Yasmin?
So I was saying that usually the addition sign is used for concatenation, so I wasn't sure if this ampersand was actually for concatenation in here as well, or not.
Usually in VHDL, the plus sign is used for addition, right? So particularly between integer types. I don't think it's used for concatenation. I don't think the plus sign is used for concatenation. I think the ampersand sign is used for concatenation.
Okay.
Okay. And just see that I can see that appropriately. Yeah, I suppose that looks okay. Okay. I'm not sure that's going to compile, but I'm hoping it will. So let's just see if we can do this. I'm going to copy that. No, it's not going to let me copy. Going to copy that whole thing over and see if I can paste it here. Oh, I can paste it. And I'm just going to comment out the previous implementation. And I suspect this is not going to compile, but let's see what errors it gives us. Maybe. Now, this way of doing it, right, is in some ways a lot uglier, right? There's a lot more code, and I've only done the sum. I haven't done the carry bit. Okay? And I did get lots of errors. I thought that might be the case. I'm not sure why it's giving that particular error, but let's just see if there's something odd in the white space that I put in. Didn't think it should, but expecting entity architecture or use. That should be alright. Looks okay to me. Let's try running that again. But as I was saying, the this is a lot more complicated than just saying S is A, X or B, right? But the reason I'm showing you this on a simple one, and I'm wondering what I'm doing wrong now. The reason I'm showing you this on a simple one is because sometimes you get much more complicated problems, and it's easier to just generate the truth table and copy the truth table over into the VHDL, right? Rather than having to minimize the logic and figure out, do the Boolean algebra or use a Carnot map to minimize the logic and figure out what the simplified information is. Now, I've got text near A. See, I'm worried that that looks like a not the right A. I'm wondering if it came across as a funny A. I'll try one more time before I push it off. One more time. If that's what I did to generate this is I cut and paste between VHD line 3. I'm wondering if there's some funny white space there that it doesn't like. Yes, the problem is probably because I cut and paste between two different machines, and I've got a VNC connection that I'm using here, and maybe some strangeness came across in the paste. Okay, so let me do this. Let me just completely go back to what I had before and see that that compiles. And then I'll just type it out again. I'm just going to move that over to my other screen so I can see both at the same time. Yeah, so that's compiling. Okay, so let me do this. I'm just going to quickly type it out again. Sorry about that. And we're going to do a sum process on A and B. We're going to begin the process. We're going to end the process sum, and let's just see if that compiles like that. If you're doing this on the one machine, it which might pay to just have the information in a separate file, the new code in a separate file. So that compiled, so we're okay so far. So then we do a case A concatenated with B is, and we'll do the end case before we need to do the actual individual cases, right? And then we can say when 0 0, we do S is 0. When 0 1, we do S is 1. When 1 0, we do S is also 1. When 1 1, we do S is 0. Okay, I think that's all we need to do. Let's see if that compiles. Like I said, I'm still not convinced it's going to compile, but it's not going to give me that silly, strange A error on the entity like the simple cut and paste did. Okay, can't determine definition of ampersand. Two possible definitions. Okay. Let's see if see if I can find an answer for that. Okay, so what we might have to do is we might have to put the I think what's happening is it can't determine, VHDL compiler can't determine the type of A concatenated with B, and I think the reason it can't figure out the type is because it could be the standard bit type from VHDL, but we are using the std logic type, and it could think that it could do either a vector of bit or a vector of std logic, and that's the reason it's having the problem. So and I have just forgotten, I think it's a variable is what we need. Right, so what we need to do is up here is say variable AB, and let's say that it's standard, oh actually we've got to tell it what type it is, and our variable AB is of type std logic vector, and then we'll go we'll just go 1 down to 0, and we'll say that its initial value is just 0 0. Okay, and then here we just say AB is A concatenated with B, and then in here we do that, and let's see if that gives us what we want, something that actually compiles. No. Oh, must use. I even thought about it when I did that, but I remember that if we use a variable, we've got to use the colon equals as an assignment operator rather than the less than equals. And hopefully this will give us the, no, stat logic does not match. Oh. I didn't type it in properly, right? Remember, stat logic requires single quotes around the zeros and the ones. And so you can see, I'm not a VHDL expert. I have done some programming in VHDL, but it's a little rusty. So, and there we go, we're done. Okay, so there's our sum, and the whole point of this was to show you that if you have a complicated truth table and you don't want to just you don't want to do the logic minimization, you can just do basically dump the truth table out directly into code by potentially using a case statement. Any questions about how that works? No? Okay, it's all right. I'm going to see if I can cut and paste that back, or copy and paste that back the other way, and so that it's available correctly in your notes in OneNote.
Can I ask you a quick question?
That's one. Go for it.
When you put the variable initialization, what is the, so did you set it equal to 0, 0?
Yes.
Okay.
Yeah, so that's what this is doing here, right? It's a variable, so it's like a bucket, and if for some reason the value of that variable was used before we assigned it in the process statement, you want it to have a valid value or a known value. So it's usually a good idea to make that assignment to something that you know. It's pretty similar to normal coding, right? If you decide you want to make you want to use a variable that you don't know what the value is, then you're sort of you're chancing to the fates, depending on what the value was in the variable.
Okay.
Okay, is that all right? Okay, let's see what else. What was the other thing I was saying? I wanted to talk about. So here's the notes in OneNote, and I'll just make sure it's synced. I always want to say that if I sync something, and I never want to say it's synced. I want to say it's sunk, but I don't think that's quite right. Okay. So the other thing I wanted to talk about was, so that was Lab 3 notes, right? And I need to go back to Lab 3. I had somebody talking about Lab 4, and there was an issue just in understanding what was happening with Lab 4, and I thought it might be worthwhile going through that for the whole class. All right, so the issue was that if you've got A set to 1 and B set to 1, and the subtract input on your adder subtractor set to 1, so you're going to be doing a subtraction, then what does that mean? Well, A goes straight through, so A just goes in as 0, 0, 0, 1. B has two things happen to it. For a start, because the subtract input is set to 1, right? The subtract input set to 1. For a start, all of those exclusive OR gates on the B inputs cause B to have its change to its ones complement. So 0 goes to 1, 0 goes to 1, 0 goes to 1, 1 goes to 0. So the first thing that happens is that there's a ones complement happening. The other place that the subtract input goes to is the carry input on the low order bit, right? So what that effectively does is it effectively adds 1 to the ones complement of B. And that whole operation, ones complement plus 1, is called the twos complement, right? That's what that is. So what we're really doing when we have 0, 0, 0, 1 as A and 0, 0, 0, 1 as B and 1 as the subtract input is we're adding 1 to, well, unsigned binary 15, right? Or signed 2's complement minus 1. So then if we do the addition, 1 and 1 is 0, carry the 1. 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 Right, so that's our carry 1 there. So the output of our circuit gives the correct answer on the low order 4 bits, or on the sum outputs, right? 1 minus 1 is 0, but maybe it's counterintuitive, but the carry bit is going to be a 1. Okay, so that's just the way the circuit works. And the same thing happens if you've got the same values on A and B, and you set the subtract to 1, then exactly the same output happens. In this case, we've got A is 7 and B is 7, and we're subtracting again. So 0, 1, 1, 1 goes to 1, 0, 0, 0 plus 1, which gives us 1, 0, 0, 1 as the effective B addition to 0, 1, 1, 1. And again, we get the same 1 and 1 carry the 1. 1 and 1 is 0, carry the 1. 1 and 1 is 0, carry the 1. 1 and 1 is 0, carry the 1. And so we get a carry bit on the out, and we get all zeros in the sum bits. Okay? All right. So what can we do next? Well, I wanted to talk a little bit about Lab 4. It should be due this evening, so I'm hoping you've all been able to finish it. I'm going to give some time later today for it, so we'll do that. But I wanted to think a little bit more about Lab 4, okay? And not for Lab 4, but the circuit in Lab 4, right? The circuit in Lab 4 is a 4-bit adder subtractor. Okay, so we've got A, which is 4 bits, B, which is 4 bits, and subtract, which is 1 bit, as the inputs. If we did the test bench for this the way we did the test bench for Lab 3, and we wanted the test bench to be exhaustive, that is, testing every possible combination, then, right, those inputs, there are 9 bits on the input, which means that we need to have 2 to the 9 or 512 test cases. I'm not asking you to do an exhaustive test for Lab 4. I'm only asking you to do a representative sample. But if you're actually doing this in a real situation, usually you want exhaustive testing. So it would be nice to know how to do exhaustive testing in VHDL. And the way to do exhaustive testing is with loops. Right? We haven't done loops, we've just done sequential, maybe conditional, given the case statement we just talked about. But it would be nice to be able to loop through a variety of values, 512 potentially values, in order to do exhaustive tests. So let me quickly have a look for loops. And that is on page 82. It should have been just after where we were. So let's have a look at that. So again, I'm going to be on the, there we go. Right, I'm going to be on the VHDL, what's it called? VHDL Notes tab within OneNote. I just thought that maybe I should figure out what the default font. Yeah, I should probably make that a bit bigger, shouldn't I? And I generally prefer fixed width fonts. Okay, I don't know whether that's going to help at all. Certainly didn't help the menus. Okay, so just like a lot of other programming languages, there are several different ways. In fact, let's go with the blue so you can see it on the white. There are several different ways to construct a loop within VHDL. Right? The loop one allows you to create an infinite loop, and this is sometimes needed, particularly if you've got an internal clock that you want to generate and keep generating and not stop. Okay, so here's an example. Right, so loop, and the clock goes to 1 after 1 nanosecond, the clock goes to 0 after 1 nanosecond. Right, so here we start, we don't know where it was, but after 1 nanosecond the clock is 1, after another nanosecond the clock is 0. So we end up generating so this distance here is 1 nanosecond. So we end up generating a clock with a 50% duty cycle. Everybody remember what a duty cycle is? Jacob, do you know what a duty cycle is? No? Not listening? No clue. Wei, how about you? Thanks for answering, Jacob. How long the signal lasts? Sort of. Okay. Right, Justin, that's closer, right? So the duty cycle is, let me just write it out. The duty cycle is, well, the way I think about it is how long the clock is high versus the period. Right, so in this case, let me get a thinner one. This is the period, right? So the period is 2 nanoseconds. It's high for 1 nanosecond in that time. So 1 nanosecond divided by 2 nanoseconds equals 0.5 or 50%. Right? So that's the duty cycle. It's what proportion of the clock period is the clock high. And it's not necessary that it's always 50%. You get some clocks that have quite a small duty cycle, right? They might look like that. And these two are supposed to be the same width. I just can't draw them that way. Okay, so that's one way to do a loop. That's probably not very useful for the problem I posed about simulating all possible inputs to our 4-bit adder subtractor. All right. So let's go on. There's also a while loop, and here it's just like a while loop in any other language, right? It checks the condition. If the condition is true, then it keeps looping, right? If the condition is not true before it enters the while loop, it doesn't enter the while loop. If the condition goes false after it's been looping through the instructions inside it, then it'll exit the while loop. Right. So in this example, so these are actually kind of cute. This was the way they suggested to do a clock. Right. But here's another way, and it's doing virtually the same thing, but it's doing it in only one statement, right? It's saying that the value of the clock is equal to the logical NOT value of the clock after 1 nanosecond. So it's doing the same thing as the previous clock version, but it's doing it in a single statement. The other thing it's doing is it's allowing an enable, right? So the clock will only continue to change if that enable flag is 1. If the clock is not if the enable is 0, then the clock will not change, or rather the clock will exit this while statement and the process will end. The next time the process gets called, that enable, if the enable is still 0, then it won't change the value of the clock. Again, kind of interesting, but it's not what we need as far as testing all possible values. So let's continue. So here's another one, a for loop. It's a loop with a counter and executes the number of times in the range specified, right? So for identifier in range loop, sequential statements, the identifier, this thing here, is something that you choose. It's a name that you choose, and that's the loop variable, right? And it's effectively defined by how you set up the range, and this will this for loop will go through all possible values in the range that you specify, in that range there. Looks like the range needs to be previously defined, and you can have all types. So for example, if you've got if you've decided to have an enumerated list of states in your design, then you can set up a state list with idle, go, stop, etc. And then the range in the for loop is just that list of states. Okay. I thought there might be a better example on the next page. Let me see if I can find a better example for you. Nope, not in those. So let me see if I can okay, so for some reason this doesn't this is coming out of Google's cache, so it's a little annoying, right? But here's some simple examples, right? Here we've got for I in, I think that should be 0 to 3 loop, right? And we can use the value of I, right? And then if the variable we're in our sensitivity list equals the loop counter I, then we set one of the bits of Z to be equal to 1. Okay, so then let's have a look at what else we've got. Right, here's another simple example using the to keyword. right, for I in A low to A high loop, and we do we do those values there. Here's some other examples. This is using the type keyword, where we can create an enumerated type, and here we've got the type primary, and it can take on values of red, green or blue, and the type color is an array indexed by primary, and it is an integer of range 0 to 255. And then the for loop variant, right? It's just going to iterate through the primary value.
Can I ask you a question?
You always ask a question about asking a question. Of course you can.
know.
Go for it.
We're setting up the array for color. Is it saying that it's setting up multiple arrays within it? So like red has a value between 0 to 250, green has a value between 0 to 250, and blue has a value 0 to 250?
That's correct. So this is setting up this line here, and let me just make it bigger so maybe it can be seen a bit better, maybe. No, it's not letting me. Why isn't it letting me do that by the keyboard? Right, so that's what, yeah, it's exactly right. That's what this line is doing, right? It's setting up an array with indices of type primary, so red, green and blue, and each element of the array is of type integer, and that type, this particular integer, is in the range 0 to 255. Okay, does that make sense?
Yes.
Yeah, okay. Okay. And here's perhaps an even simpler one, right? For I in 1 to 10 loop, and so it's just going to keep looping through the values from 1 to 10. And that's probably, or possibly, closer to what we want in it, if we're doing testing 512 possible cases, right? We might want to loop from, I don't know, 0 to 511, or yeah, we might want to do that. So let's think about how that would work. Right, so where's my OneNote gone? There it is. And I'll go back to my Lab 4 notes. There we go. So we've just seen, what did we just see? We just saw something like that. Let me see if I can copy that and put it into our OneNote. And we'll paste that there, right? So that's the sort of thing we want to do, but we want to, for a start, let's just change that, change the name to inputs, right? So now we've got a way to loop through all 512 different possible inputs. And what do we want to do? We want to set A to be something, we want to set B to be something. And I've forgotten what we called it. Let's just call it subtract. We want to set subtract to be something. And then we want to probably do an assert. And then we probably want to wait for 100 nanoseconds, 10 nanoseconds, something like that. So now the problem is, how do we get those values? How do we get A? How do we get B? Right? So the starting value of our input is 0, but really that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That's 9 bits. So what we want to do probably is split it up something like that. So we've got the S, maybe that's B, and that's A. I don't know why I'm putting a dot there. Okay, so we want to take our inputs variable, which is the variable we've named, right? And we want to pull it apart and use the low order 4 bits for A, the next 4 bits for B, and the top order bit for our subtract. Does that make sense? So there's a few things we're missing. One of the things is how do we know what the right output is so that we can assert to test it? So I'm gonna push that off. I'm not gonna deal with that right just yet. So I'm just going to comment that part out. So the next question is, how do we get those bits? And the answer is we can extract those bits. And I probably got the syntax wrong, but let me just do a quick. I think it's just something like it's either like that or 3 down to 0. But let me just put these in first. So what's that going to be? That's going to be 7 to 4. And that one's going to be inputs 8. Can everybody see how that's working?
Yes.
Zach, how about you? Can you see how that's working?
So this is input into the test bench?
So this will be put into the test bench rather than the. I mean, you can use loops within standard VHDL. It's just I'm introducing it because in the test bench, because it's just a little easier to bootstrap from there rather than come up with a design that requires a large loop.
Okay.
Okay. Nothing from Zach? Let me see if I can... Celine, how about you? No response? Okay. So, what I'm going to try now, if I can, let me do it on video rather than off video. So I'm going to close this project. This was my redo of Lab 3. I'm just going to see, I don't know whether I have a Lab 4 here. It looks like I might have something like a Lab 4. Okay, thanks, Celine. So let's just have a look at what our Lab 4 code looks like. Right, so this one has a subtract input. Right, and we're putting the subtract input into there. However, what this design doesn't do is it doesn't use that subtract input to do the ones complement of the B input. Right? You can see the B input is brought in straight to the B input on each of the individual full adders. So it looked like this compiled at one stage. Let's just see if it compiles again. And I don't know whether I'd forgotten whether I added, looks like I haven't added a test bench. So I might need to add a test bench once it's finished compiling. Okay, so that compiled okay. Remember to add a test bench. I need to say start test bench template writer, and it looks like it did it, and it added it into the simulation model sim subdirectory 4-bit adder.vht. So let's just I tend to like adding it here so that it's part of the and there it is there, VHT, it's a test bench. Oh, one thing that I ran across during the week is if you forget to set up your format for output netlist as VHDL, if instead you've got it as Verilog, then you will not generate a VHT file, you will generate a VT file, and that test bench will be in Verilog rather than in VHDL. Okay, so I've added that, and let's see what we can get. I don't know whether I can, maybe I just got to go here to open it. I thought it might show up better there, but so there's my test, which is completely empty. And remember, what I want to do is I want to do something like what we were talking about in over here. I'm not going to generate the asserts today, but what I want to do is I want to go through and test every possible output of the so let's see if we can do that. Okay, so for inputs, and what do they call it? In 0 to 511 loop, and then end loop. Not quite sure why it's doing strangeness there. So then what do I need to do? I need to set parts of the inputs to A, parts of the inputs to B, and parts of the inputs. So A gets inputs 3 to 0. No worries, Zach, that's okay. And then B gets the inputs there, and actually it's called something else. It's called A in, isn't it? And B in, and subtract gets there. And what I'm going to do what I'm going to do is I'm going to wait for 100 nanoseconds just so that I can see the outputs. Otherwise that'd loop through very, very quickly. Now I'm not sure that's going to compile. Like I said, I'm not sure about the 3:0 notation for the getting access to the subbits. I'm not sure it's going to give me the right type for the counter variable. So let's see how we go. Oh, look at that, it compiled. Wonders will never cease. So hopefully that'll compile and everything will be good. And I'm just going to kill model sim because I want to start the, okay, so there's my, everything's happy. There's a few warnings, but we know those warnings. So I'm going to rerun my simulation tool. No, this isn't necessary for Lab 4. You should have finished everything necessary for Lab 4 last week. This is just, I'm just using Lab 4 as a springboard into more stuff that we need to learn for VHDL. Okay? And in fact, this is going to be, I'm hoping that we'll see something. Don't worry, Jacob. I'm hoping that we'll see something that is problematic, and that will be for Lab 6. Okay, so we got a work product. What we didn't get is we didn't get a compilation, and that's because I think I forgot to add. I've forgotten where it is. That's set up. I think I forgot to add the test bench to the compilation, right? Yes, I forgot to add a test bench, right? So I've generated the test bench. I've written code in the test bench. The test bench maybe didn't compile, so I need to create a new test bench, and this one's called let's call it full range of inputs, right? And I'm going to take it from my simulation model sim VHT file, and I'm going to add that, and I think that's what I'm going to do. Okay, and then I can apply it. And now I think I need to recompile because I don't think it tried to compile my test bench before. So maybe there's still an error in my test bench. The way I saw that is in that in Model Sim, in the work directory, if you like, there should have been a test bench, because in Model Sim what I want to do is I want to run I want to simulate the test bench, because that's the test bench is what sets things up for me. Okay, it looks like it all compiled, so now we can try again and go Tools, Run Simulation Tool, RTL Simulation. And it might take a while to start up. There we go. Ooh, lots of errors. Okay, so this is one of the problems. Mantissa part of integer-based literal terminates with blur. Should be colon. So let's just see what where that's saying. So it's, for some reason, it's not liking my my test bench. I'm just going to go here, and there's my, so this is, when I opened this before, this test bench wasn't under the work directory, so that told me that it hadn't been compiled. I'm just going to recompile that and see if I get the same errors. I do get the same errors. So that means that I'm going to have to redo my test bench, and I suspect it's that. Let's just quickly try it here, but I will go back to Quartus. Okay, somebody's typing. The slice constant inputs of slice name is not an array. Okay, so let's deal with that. That's what I was expecting to happen. So I think it's Anthony. Can you mute, please? I can hear lots of typing in the background. Thank you. Okay, so let's. So what's happening here is the type of inputs is not the right type to use this notation. So let's just go back here and reload that. Right, and we've got that. Let's just see if this compiles now that I've changed it. So the problem is that the loop variable inputs is probably just an integer. It's not a std logic vector. And VHDL is very concerned with the, ooh, it compiled. I suspect that shouldn't have happened, right? And VHDL is very concerned about making sure that my types of my variables are right. So let's just see if we can Now, one of the things in the IEEE library is that you can there are conversion routines that let you do conversions between the different types, between integers, which is probably what inputs has been defined as, and stated logic vectors, which is what we really want inputs to be. So let's have a look at how we do that. So what we need is something like, where is it going? So we're going to make a variable, right? Wish I could type, it'd be wonderful. Variable, and we want this to be, let's call it converted inputs. And it's of type stated logic vector 8 down to 0. And I've forgotten the format. I should have checked the format for defining a variable. Sorry about that. And I think, in fact, why don't we do this? I've been going for too long. I normally give you a break a little earlier than this. So let's take a 10-minute break. And I will try and nut this out during the break. And we can go from there, okay? So 10-minute counter, 2-minute timer. Apologies for that, I just got a little carried away. So let's do that. Does anybody have any questions? Let me just reset that. Does anybody have any questions before we have a break? No? Okay. Let's have that 10-minute break, and like I said, I'll get this sorted out by the time we come back. Okay, and we're back. So let's just go back to our test bench, and I was having problems with where is it gone? There it is. I was having problems with converting things. So what I've done is the issue is that I was trying to access the inputs loop variable as if it were a std logic vector, right? And unfortunately I can't do that. So what I have to do, it probably comes in as an unsigned integer, would be my guess. So what I have to do is I have to convert it. And the IEEE library has a function called conv std logic vector, which takes a variety of inputs, types of inputs, and lets you convert that to a std logic vector of a nominated length. In this case, remember we've got 9 bits that we're cycling through. So this one is 9 bits. I think somebody is probably not on mute because I'm hearing various values. Is anybody? Sorry, I sort of launched into this. Is everybody okay with where we are? You understand what I'm trying to achieve? Yeah. Let me go with bingo again.
I think so.
Yeah. Mohammed, how about you? You okay with everything? You're still a little confused. Okay. So part of the reason I ask is I suspect that's the case for, I don't know, between half and a quarter of the class. So let me just go back a little bit, and then I'll try again. Okay, that's all right. That's okay. I realise it's probably a little bit like trying to drink from a fire hydrant. I apologise. That's sort of the way it is, and that's part of the reason why I video this stuff so that it's available afterwards. So remember, and this isn't the full 4-bit adder subtractor. As I said, it doesn't have the inversion on the B input where all of those exclusive OR gates are, but it does pretty much everything else, right? And there should be enough here to allow you to get to where we want to go. So what I'm trying to do now is I'm trying to see, oops, I didn't want to do that. I'm trying to see, well, here are my inputs. Actually, no, on this one, here are my inputs, right? This is the top, this is the top level entity for this project. It's the 4-bit adder, and it's got a single std logic input on the subtract input, and it's got 2 4-bit inputs for A and for B, right? And there's std logic vector 3 down to 0. And then I'm pulling out the individual bits to go into specific full adders, and that full adder entity is also in this project. What I'm trying to show now, and it's actually a lead in to lab 6, not lab 5, lab 6. What I'm trying to do now is I'm trying to generate every possible input to our 4-bit adder, right? So I'm trying to cycle through every possible value of subtract for every possible value of A in for every possible value of B in. That turns out, because there's 1 bit in subtract and 4 bits each in A in and B in, that's a total of 9 bits. So that means I've got 2 to the 9th possible input values, input vectors if you like. And what I'm doing in the test bench is I'm trying to generate all 512 possible input vectors. And so 2 to the 9th is 512. So in order to do that, I'm taking the counter variable, which goes from 0 to 511. That counter variable is probably of an unsigned integer type. Unsigned integers are not stated logic vectors, and unfortunately, if you remember, our A in and B in are stated logic vectors. So I can't just do the assignment that I did have. I can't just pull out a piece of inputs and put it into A in, or a piece of inputs and put it into B in, or a piece of inputs and put it into subtract, because they're incompatible types. So what I have to do is I have to convert from that unsigned integer value, which is what inputs is, into a stated logic vector. And the IEEE library, or at least part of it, has a function called conv stated logic vector. And that takes the other type, which could be many, but in this case probably unsigned integer, which is the inputs variable, the loop variable we're using, and then at the number of bits you want to convert that to. So in this case it's 9 bits we want to convert it to, right? And I'm putting that into a variable which is a stated logic vector 8 down to 0, which is 9 bits. And once I've done that conversion, and that's all that's happening, is just converting inputs to a stated logic vector. And once I've
Is inputs always decimal?
I didn't say
in 0 to the binary of 511.
Right. So what the type of inputs is will depend on this range, right? My guess is the compiler has decided that it's a 9-bit unsigned integer. However, if I did something like this, right, -1 to 511 for whatever reason, then it would probably convert it to what would that be? Probably a 10-bit signed integer. So you've got to be a little careful that you know what types the loop variable is being converted to. Does that answer the question?
Well, I was asking about inputs being an integer type integer.
Right.
That means you have to convert it to a type bit, the logic STD logic vector, right?
Right.
So didn't you have it initially already stood logic vector type?
Well, I haven't defined it as a particular type. The variable, the loop variable, gets defined as part of the for loop, right? So I haven't said what type it is. I'm not sure whether I can do something like that, right? Maybe, and this is a guess, I don't know this is going to work. Maybe I could do that, right? So I've predefined what value I'm saying inputs is, but I suspect that's not going to work. But let's try it, right? That way, I suspect it's not going to like that. But let's just see what the compiler does. It's thinking about it anyway. Ooh, it might have done it. Ooh, so maybe is that what you were saying, Yasmin? That maybe you?
Yes, that's what I was saying.
Okay, so you're right. That would be another way to do it, right? So now, rather than depending on the compiler generating an implicit type for inputs, we've predefined what type we want inputs to be, and that makes life that's probably a better way to do it. Okay, so now we've got we've predefined what the input's loop variable type is, and so we don't have to do the conversion. Part of the reason I did it that way was so that I could introduce the conversion, but that's okay. And then the other piece is it's in a different part of the IEEE library. It's in the arith part, Stdit Logic arith part for arithmetic. So I need to use that part of the library, the IEEE library, if I'm using conv Stdit Logic Vector. Okay, that's good. Let's go back over here, and I'm going to reload, and I'm just going to go and check that that compiles. Okay, I'm just going to go back here and check that I can compile everything, just in case, because there is a bit of yeah, see, for some reason the model sim compiler interprets this differently from the Quartus compiler, right? So it's saying that this is not the right type, which is probably why I did it the other way. Right, this compiled perfectly happily in Quartus, but it's not compiling over in Model Sim. So I'm going to back out my changes. It's a bit unfortunate, but that there's this incompatibility. Yeah, I'm a little surprised that that's true, or that my explanation is true. I'm just going to try and see if I can find out. So does Model Sim allow pre-declaration of loop variable types? It may do. I'm a little rusty on this stuff, as you can tell, so let's anyway, so this, and let's just check that compiles again. So this should do the same thing, and if in a little bit more convoluted way, right? Because I have to use that conversion function out of the IEEE library in order to convert from the unsigned integer type of inputs to a std logic vector type of the A and B and, well, subtract sort of. Okay, so that worked. And let's reload, and recompile and just check that it compiles. That compiles. And then I'm going to simulate again, so I'm going to close the previous simulation. Crash, bang, wallop. Okay, so then I'm going to add all of those selected signals to the wave. Looks like it did it. Now, normally I just go with 100 nanoseconds, right? But this is going to go through 512 lots of, I think it was 100 nanoseconds, right? So we want that run duration to be a little longer. So I'm going to say 512, so 5,120 nanoseconds for our run. And we'll do that, and we'll do that. Okay, so there is our there's our A values, right? And you can see the least significant bit is changing at one rate, and then the second least significant bit is changing at another rate, etc., etc. And each rate is half the previous one, which is what you would expect. And then B is changing even more slowly, right? And I'm a little worried, I'm a little worried that it looks to me like we don't have everything. So I'm just going to run it again and again and again. Okay, that's better. So now we've got, right, A is changing the fastest because I'm pulling A out of the least significant bits, and then B is changing even more slowly, etc. Right? And then here are my outputs. And remember, I haven't done anything about asserting anything yet, but at least I'm now exercising all possible inputs and outputs of my circuit. Can anybody see a problem? Adonica, can you see a problem?
Not really looking rich.
Okay, let's see if somebody else can spot anything. Matt, can you see a problem? Yeah, so can you be a bit more explicit about where you see the strange timing, Daniel? Right, and that's pretty much the issue. Let me just see if I can forgotten how to zoom. See if I can. There we go. Right, so the issue I'm seeing, the one that I'm suspicious of, are these glitches, right? You can see that they're very short. Right? Even though I zoom into to a quite a small area.
Could you change the colors of the waves? Because right now I can't tell which one goes to which one. It's kind of confusing.
Okay, I don't know how to change that.
Right click on the name and properties.
Okay, and then format.
No, view, wave color,
View.
in the color setting.
Oh, I see. So let's make it red. Is the one that I'm. Okay, so the one I'm looking at now is the carry out, and there's only one glitch in it, but it's this one here, right? You can see it's 0000, whoop, glitch up 0000, and that glitch is happening at a transition. Okay, and then you can also see.
Same thing with mine.
Sorry, say that.
I had the same thing happen with mine, but that was when the carryout was originally 0, and then for one of the test cases, the carryout was 0, and then the next test case, this carryout was 0 again. So it just goes up and then comes back down.
Right.
That's what for me.
So, does anybody have an idea about what's happening? I think I've mentioned it before earlier in the course.
I might have a theory. I'm looking at AN where it's between 0011 and then it switches to 0100. I vaguely remember you mentioning something about like I forgot the name for it, but it's when you change one bit. But in this case, it's changing 2 bits at a time, and it might be giving off some weird interference. Is that a possibility? Because you see to the left where it's going from 0011 to 0100.
Yeah.
You're changing the 11 to 00. You're changing 3 bits at a time and not changing 1.
Right. And
Are you talking about propagation delay?
yeah, basically that's the issue, Quentin. And yeah, the reason for the I think that was Yasmin. Yeah, the reason is the propagation delay. Let's just where have I got the picture? On lab 4, I suppose it is, and I'll save that image into downloads. Let's go back to here. I think this is on lab 4 notes. That's good. So let's just insert that picture. And it's a bit tiny. Let's make it a bit bigger. Okay, so what's happening? And let's go with blue, say. What's happening is, you're right, we're changing the inputs, right? And then we're expecting the output to happen immediately. But the output C out happens immediately, as quickly as S out does, more or less. But C1, and in fact possibly even S1, is going to have at least that propagation delay. Right? But then if C1 is needed to compute S2, then we've got another propagation delay. And if C2 is required to calculate S3 or even C out, then we've got yet another propagation delay. So what's happening is the inputs of these are changing instantaneously. Remember, I don't have these exclusive OR gates in the circuit, right? So there's no propagation delay due to them. If you have those in the circuit, it's possible there will be a propagation delay due to them also, right? But in order to look at C out at least, there's a whole series of delays possible when A and B, or this is the subtract input. There's a whole series of delays possible between these changing and the outputs settling to the right value. Right? And that's what's happening in these glitches. And it happens particularly, as I think it was Quinton noted, when there are lots of bits changing. Right? If there are lots of bits changing, then there's going to probably be more propagation delays required or happening before we get the right output. So that's what's happening on with those glitches.
You can also see from 0100 to 0101, you don't even see it.
Yeah, exactly.
So it could be when there's multiple bits changing at once.
Yeah. That's probably more likely to happen when there are multiple bits changing at once, particularly as you noted that there's 3 bits changing going from there to there. So I suspect that's probably makes it more likely. Right, here's another example, and here we're going from we're changing 2 bits there, I think. Right, and we get a 1-bit change, but there's several, particularly on the red. Carry out is the one where it is most likely to turn up, because it's sort of the last thing that gets calculated in that train, right? It has to wait until the potentially that, I mean, there's also another there's also potentially another tau p here, propagation delay here, going through the last full adder in order to get C out, the carry. It's probably less likely on the lower order bits, right? But even, right, there's let's make that a different color so we can see it. Let's see if we can make it a pink color, a magenta. Right, so you can see even not the low order bit, but the second to low order bit has a glitch in it. So even one propagation delay is causing a glitch in there. I haven't seen any glitches in the S out 0. I haven't seen any glitches in that one yet. But there are lots of glitches in the others. Right, you can see them happening. Okay. Any questions about that? So the two pieces of VHDL that I wanted to talk about today were loops, right, which we've talked about, and case statements, which we've also talked about. Okay, I've also, as part of that, talked a little bit about variables, and about the concatenation operator, turning a std logic, or turning two std logic variables into a std logic vector variable. And you can do that with multiple variables, right? If I had C and D and E, I could concatenate A with B with C with D with E and end up with a length 5 std logic vector. And then today's, again, this is not required for the write-up of Lab 4 at all. The only thing that's required in the test bench for the write-up of Lab 5 is that you exercise some of the expected inputs and outputs and test them using the assert statement, and that you show that there are no errors in your implementation. Or sometimes it's fun to induce an error and talk about that in your lab report.
In Lab 4 or 5?
In Lab 4, right, the one that's due today. You should be able to see that, I think. Remember, the write-up for Lab 4 is aimed at being in a more formal lab report format, and there should be I think I attached the notes, my usual notes on lab reports to see the format. And then let's just go to the rubric. Right, so this is the rubric, and we've got that VHDL compiles, that it implements the full adder plus 4-bit adder, and this should actually say the subtractor as well, right? That all the naming and the formatting is good, and that the test bench verifies correctness. What I'll do for Lab 5 and subsequent labs is I will change over the rubric to include the sections in that notes on lab reports that's attached to this one. I just want you to, at this stage, I'm more interested for Lab 4, I'm only interested in these things, but for Lab 5 and going forward, I'm interested in you reporting it a little bit more formally. I do want you to practice on this one, so please do. But yeah, the rubric is not showing the it's not it's gone. There it is.
What do you want us to turn in?
I basically want you to turn in a Microsoft Word or PDF document.
Okay.
Okay. And I tend to not like seeing large swathes of code in the body of a report. If there is, like for Lab 4, right, it's possibly, if your architecture looks like that, or if your whole implementation looks like that, that's probably okay to stick in a figure or something in the body of the report. But in general, I prefer to see code in an appendix at the end of the report. In particular, this time round, your VHT, your test bench is going to be long, so I expect to see that, but it doesn't. It should just be at the end of the report. You can either include it as text in the report, or if you want to include it as an included file inside the Word document. You know how you can insert files into Word documents. If you want to include it as an inserted file into the Word document. I'd like to see the full test bench. I realise there's a lot of boilerplate code there that you didn't write and doesn't actually tell you much, but I'd like to see the whole test bench so that if necessary I can try to compile it. Okay?
I already submitted the assignment, so I didn't have the test bench in there. Should I just email that to you, or?
No, so I never accept email assignments. They all have to go through Blackboard. What I would do is let me just have a quick look at it after class, and if you want to resubmit then go ahead, or if you want to resubmit now with that added, that's okay too. Okay?
Right.
Okay, so Lab 5. And unfortunately, before we do Lab 5, we've got to figure out lab groups. So let me, sorry, let me get off that machine and onto this machine. So I already have, and I need to, I already have 3 lab groups. I need to add Jordan to this group, so let me just do that now. Okay, so I currently have, and I'd prefer to leave those 3 groups as they are now. I now have 4 other people with boards without partners, so we should spend some time now sorting out who's going to partner with these people. And I'll go into them one lab at a time. Let's start with labs 2. So Bray, I don't know whether I saw Bray on. There's Bray. Okay. So somebody wants to partner with Bray, and who's this? Yasmin has a board, and David has a board. Yeah, lots of people do, Daniel. And Kyle has a board. Okay, so I have 5 other boards that I need to. Who's well, I just went through the 5 people. What was it? Bray, David, Yasmin, and Kyle. Currently have boards, and I need 5 other people who are happy to pick up a board from me. And Kyle, are you okay with Anthony?
Sounds good to me.
Okay, so I'll add. Oops, sorry, I forgotten where Kyle was. There we go. So let me add Anthony. You'll take David. Okay. Oh, well, let me do this one at a time. So Anthony. And Jacob with David. Okay, I've forgotten which one's which now. So that's Yasmin. Is that David? That's Bray. So Bray was Daniel. Bray, are you okay with Dan? Okay, we can do that. So there's Daniel. And did I get David? There's David. Is David on? Yeah, David is on. You're okay with... You're welcome. David, you okay with partnering with Jacob? Okay, so let's do that. Okay. Anybody? Yasmin, is there somebody you want to pair with? I thought I saw Quinton is asking. Is you okay to partner with Quinton, Yasmin? Okay. So let me add Quinton. There we go. So we have 2 3-person groups and 1, 2, 3, 4, 5 2-person groups. I think we might have to have one more 3-person group. And okay, Celine, that would be good. Yeah, I'll have to work with you to figure out when and where, but that's okay. We can do that. I'm buzzing past. Okay. So Celine, you'll work with Mohammed and Wei. Is that right? Yeah, shouldn't have more than one board. I want to distribute the. I only have 12 boards, and we have 27 people in the group. So I need. I thought we were only having 24 in the group, so in the class, but we got a bit more. So let's let me put Celine, Wei, and Mohammed there. So let's, and I will work with you, Celine, to get you aboard. There we go, you're on the other page, Wei. Okay, so now we just need another 4 people to pick up a board. And yeah, we'll do that. So Anthony, yeah. So I need 4 more people for a board. We can work that out. So that's partly worked out. So Celine, touch base with me outside and we can sort out a swap over time. I usually meet people in the parking lot just beside the entrance into Copernicus Hall there. The faculty parking area just near the smoking shed, I think it should be called. What I'm aiming to do, and let me so what I want to do for the next lab is pretty straightforward. right? And it's basically, I did a couple of videos, and I don't know whether this will come out, the audio will come out properly. So let me just start playing this. So the first thing is to connect up the...
So this is the start of the video to get the CET466 Lecture.
Can anybody hear that?
The first thing we need, the standard USB connector, right? And it goes into the board there. That's right, the big
Yeah, it's probably not the best. What I'd suggest is let me just pause that, and I'll grab the link. Maybe you should have a look at it directly. Okay, so there's the link to stop it being choppy, so you can see it directly. Yeah, so what I'll do is I'll turn it off. So there's a few parts to this. The first part is just using it's a standard old style USB connector that looks like that at one end and the standard USB 2 at the other. And then that plugs in beside the big red button, right? All this is doing is providing power, and I apologize, I was filming with the one hand, and right, so I just plugged it into the power, and if you press the power button now, the power LED should go on, just like that. And then what was the next bit? I think I get another bit. So then the other one is there's two USB connections. This one is the USB blaster connection, which has the ribbon cable and the black connector that plugs into one of two places on the board. And in this case, generally we're going to be using the JTAG connector. There's two. There's JTAG. There it's upside down, but you can read it. And there's the AS, or the serial version. I suggest, first of all, turning off the board before you plug anything into it. Then plugging in the USB blaster connection. And that should now allow us to program that via JTAG, and now we can turn the board back on and we're all good. Okay, so then you may have to install the driver, right? So to do that, go to Device Manager and go down to Universal Serial Bus Controllers and select the Altera USB Blaster. That may have a little yellow warning label there. Go to Properties, Driver, Update Driver, and then browse to the Quartus installation, and there should be a subdirectory in the Quartus installation called Drivers. That should be all you need to do in order to get access to the drivers. And then I didn't do it, but you type next and it should install the appropriate driver. Okay, once that's done, oh, I should have put I didn't put the title in. Okay, so now what I'm doing is I'm taking my VHDL code for lab 3, and I have to connect my variables A, B, S and C with outputs on the board, right? So they're my inputs and my outputs, and I want to connect my inputs to switches on the board and my outputs to LEDs on the board. So in order to see the pinouts, you should go to that GitHub repository for the class, right, and scroll down, and all of this green stuff shows you some of the pinouts, right? So for keys 1 through 4, it's 88, 89, 90 and 91. And for the LEDs, it's 84, 85, 86 and 87. So I think I selected key 3 and 4 and LEDs 3 and 4. So what you need to do is you need to go to the pin planner, right? It's under Tools, Pin Planner. And when you go there, that location field won't be set. So you need to set the appropriate pin number, pin underscore number, and that's what I've done for switches 3 and 4 and for LEDs 3 and 4. So there's 90 and 91, right? 90 and 91, and then 85 and 84 for the LEDs. So I've done key 3 and key 4. And if we scroll down a little bit, there we go. We've got LED 3 is 85 and LED 4 is 84. So yeah, so that's how to set up the connections from the code to the board. And now that that's set up, I can just need to recompile it. You will need to recompile it if it wasn't set up before. Once it's recompiled, click on that program device and you should get this. You may need to click on hardware setup and select the USB blaster if you haven't done this before. Usually it'll say no hardware if you haven't done it before. And once that's done, then you should be able to program it. The start button in the top left there should be ungrayed out. You should have the appropriate thing. You should just be able to press the start button and it should say progress 100%, and that should all go green and it should say successful like it did there. Okay, so that has now programmed, and you can see it's in the JTAG mode there. We plugged it into the JTAG input on the device, so make sure that matches. And then I ran it on the board. So it's now you can see that LED 4 is on already, and I'm not pressing any buttons. So that's slightly concerning. And then I'm going to press, oops, wrong button. I should have been pressing one of 3 and 4. If I press one of the buttons, then LED 4 goes out and LED 3 goes on. If I press both buttons, then both LEDs go on. Right, so there's something a little odd happening there. And what I suspect, okay, so that's, and that's pretty much what I want you to do for Lab 5. Okay, it's basically just taking what you did from Lab 3. And yes, Lab 5 is the first time you'll work in groups. And I've forgotten exactly when I set it up for, but I think I set Lab 5 to be due in 2 weeks' time, right? It's due on the 17th of October. So that gives us enough time to find yourself a group partner, for me to distribute the remaining boards. I'll get one to Celine during the week. Usually my best times are Wednesdays, usually Wednesday afternoons or Friday afternoons, but it depends on exactly what's happening with my day job. And let's have a look at the coming week. Yeah, so Wednesday should work for me. And maybe Friday evening, but it will depend. That might be a little late. So maybe sometime Wednesday or sometime Thursday morning is probably the best for me. Well, we can sort that out. Okay. So let's go to another break. If you've already finished Lab 4, which is due today, that's pretty much all I'm doing. If you have a board and want to try deploying Lab 3, we can do that. If you're in neither of those situations, if you've already submitted Lab 4 and you don't have the Lab 5, that's okay. We can probably finish now. I will be spending more time during next week's session on Lab 5 to make sure everybody's up and running with a board, or at least each group is up and running with a board. Let me just take yet another break, if that's all right. And we'll, unless anybody has any questions. No? If nobody has any questions, then we'll take another break, and we'll just go into the lab. If you have questions, I believe I resolved my issue with the bot, so just join queue should work. I don't know, Javier. What I'd suggest is after the break, I'll get you to share your screen, and we can have a debug. But maybe join the queue first. Okay, but let's have a break, and I'll come back and work then. Okay, I think we're back. So let me, where's Discord gone? There it is. Let me see I'll say who's here. Works, so Javier is next, I think. So Javier, can you share your screen? So like I said, the aim is to, if you haven't finished Lab 4 yet, to get Lab 4 done. If you want to try out Lab 5, if you've got a board, that would be good. So
Alrighty, so when I run it, I get into this error where it says cin does not exist in the macro function adder 0. Cout does not exist in the macro function adder 0, and it repeats for adder 1, 2, and 3.
okay. So yeah, let's have a look.
Do you need me to make the screen bigger or something?
Yeah, it's a little pixelated. If you could, oh, where is it? File, properties. Is that it? No, I've forgotten where it is. Let me have a look locally. That'll help me remember a bit faster. So tools. No. I've forgotten.
Alright, I set it up. I figured
Yeah,
it out.
there you go. Where was it again? Sorry.
It's tools, options,
And
and
then
then it's text editor.
yeah.
But then I'll also change the.
Okay, that's okay. I can read that. Oh, let me just see what I think Jacob came up with. Let me just see if there's a gone. I can pop out like that. That might be better. Thank you. Thank you, Daniel. I obviously haven't done this particular piece in Discord before. There we go. That's better. So what have we got? We've got cin does not exist in macro function adder 0. So the problem is that should port map your component full adder that looks okay. Let me just have a look at my code. I don't think my code is any different from your code, pretty much.
No, I use yours as a very hard guide.
So what I want you to do, Harvey, is go to I've forgotten where it is.
Do I need to do the pin output? Like
no, you don't have to. So at the moment, go to project and say clean project. And now try recompiling.
do I do all revisions or revision name?
All revisions, just to get rid of any possible. Sometimes, just like any compiler, VHDL gets itself into a mess because of it uses what do you call it, intermediate files. And sometimes those intermediate files, no, it's still doing the same thing. Port cout does not exist in macro function adder 0. So I've got I'm a little concerned in your, in there you've got 8 entities. And I'm wondering whether you've got...
Yeah, I was just trying to figure out what they lead to, and they don't.
Okay, thanks, Adonica. You should be able to bang leave queue if you don't need help. So it's exclamation mark join queue to join the queue and exclamation mark leave queue to leave the queue. Okay, so I still don't understand. Yeah, Javier, you should have come out of the queue when I did who's next anyway, I think.
Yeah, I didn't put this. I put a space in between on purpose.
Oh, did you? Okay, thank you. Okay, port C in does not exist in macro function edinort. Can you just open your full adder? Have you? Is your full adder inside this project?
I'm sorry. Where is a full adder a different?
Well, where have you defined your full adder? There should be a VHD file that has your full adder. So right click on where it says cyclone and go to settings.
Okay. Oh, so there's supposed to be a separate file that has full adder already made.
Yeah, you need to. So there should be two. There should be two files in here. So what I have in mine is I have the full adder and the 4-bit adder, right? So I think what if you haven't included a full adder definition, it's trying to make one up and it can't find it, right? So in mine, let's see if I can open it up. Right, I have a full adder definition that defines everything, and that port statement there is the same as the port statement on my component definition.
I'm sorry, I missed what you just said.
So the port statement in the entity of the full adder is the same as the port statement on the...
And that's the same as the Lab 3 full adder, or adder?
Well, the Lab 3 was only a half adder, it wasn't a full adder, but yes. Right, Lab 3 didn't have C in, it didn't have a carry in, it just had A and B as inputs. And then the full adder has, right, the exclusive OR of A, B and C. And then the carry out, remember it's, where have it got to? I've forgotten where it got to. Yeah, so you're going to have to, let's go to labs. Oops. Right, so this is the truth table for the full adder. It's not the half adder that we did in Lab 3. Okay?
Okay.
I think that'll. What you can do is you can create a new file and use the. In fact, I'll paste this to you, but you can use the port statement that you've got and. But that will be the entity statement that you need for the full adder. Yeah. Probably capital C in just to make sure it I don't think it matters, but
yeah,
it just reads a bit better.
I was just in the middle of typing. My microphone is nicely in front of my keyboard.
Of course. Okay.
Alright, I think that should fix it. I'll let you know how it works.
Yeah, just come back. I'll be around for the next little while.
Okay.
Okay. Thanks, Abby. Okay, I think Wei is next. Let's just check. Yeah, Wei, so what's up?
I have a question about the Lab 4 in Blackboard.
Mm-hmm.
It says multisim plus Quartus plus for beta. Does that mean that we have to also need to do like a multisim for Lab 4?
Yes, I want you to do this in both Quartus and in multisim.
And what you want from the multisim is just a waveform, right?
Well, I'd like to see the circuit in multisim, but also the waveform as well. Yes, please.
Okay, alright, sounds good.
Okay.
Yep.
Okay. Yeah, you don't have to. Once I call who's next, the port that person gets pulled from the front of the queue, and the rest of the queue's left. So you don't actually have to explicitly pull yourself out. Right, and there's nobody in the queue. So I'm assuming that means everybody is happy with Lab 4 and or trying to do Lab 5. So if there's what I might do is I might stop the recording, and I'm happy to hang around for the next little while. But if nobody has any questions over the next little while, I'll shut down early. If you're happy with where you are in all of this, feel free to leave. I basically want you to get Lab 4 done. And yeah, that's about it.
Actually, I have another question.
Okay, go for it.
So I try to run my program, but for some reason, I'm getting some errors on my VHDL.
Okay. So do you want to share your screen, and I'll have a look at that?
Sure.
Where did that come up? There it is. Okay, so I can read that. Okay, so if double click on the first red line in the okay, so the problem here is it's really annoying, but the last statement, the S out statement in a port, doesn't require a semicolon at the end. So remove the semicolon from the end of the line there. Now try compiling it again. And let's see if we can get that. Okay, so double click on the next red line, that one. So what's that saying? It's saying near text. So you've got two open parentheses on that line. It should only, and there's no matching close parenthesis. So remove, either add or closing parenthesis, or remove the open. Okay, try that. Try compiling that. Positional associations must be listed before named associations. That's a bit cryptic. Double click on that and see what it says. Positional associations must be listed before named associations. Oh, so I think what's happening here is, it's a bit cryptic, but you're connecting several outputs to the same variable, and you're connecting that those C out goes to C out in all of them is probably not what you want to do. You probably want to say C out for adder naught goes to C naught, for adder 1 goes to C1, for adder 2 goes to C2, and the last one, I think you've named the output port Oh, that's the other thing. So see, you've named the, well, they're both called count, right? The 4-bit adder has the 4-bit adder. So Yasmin, no, I haven't checked it. I'll check it once I've finished with Wei. So you see, you haven't called the carry out C out. You've called it count. Right, and so C out doesn't exist as a logical name. You've called it COUNT.
Oh, right there. Okay.
Yeah, so
it should be C out, right?
Yeah, it should be C out rather than count, and then it's also C out in the component definition as well. So check that. Just past the middle of that line, line 14, where it says S comma count, it should be say S comma C out. Line 14.
40?
1-4.
Oh, 1-4, 40. Okay. Oh, right.
So try compiling out. I still think you're going to have a problem because of all those outputs are connected to the same variable, but it will be a different problem. No, it's still got the same error. So double click on that. So again, yeah, again, I think you're going to have you've got for adder 3, 2, and 1. The C in connection is the same, and the C out connection is the same for all of them. I don't think you want that. I think the C in connection for adder 1 should be C0. So C in goes to C0.
Oh, shoot.
No, not... C in is right. I think C in is right because that's the name, but it goes to, so equals greater than C naught.
I don't know why. It's like deleting the word as I type.
Yeah, you probably, it's probably got a, what do you call it? There's a mode where it'll overwrite. There you go. And then
you click insert, it will stop.
Yeah, I said insert. Yeah, a lot of editors used to do that, but they've stopped doing it. But some of them, older ones, still. So they're on that same line 19. The last C out should read C1. No, not that one. The other one. Yeah, that one. And then up, just go straight up, and that one should say C2.
Okay.
And then on this line, adder 2, the C in should be connected. I don't think you want to do that. I think you've defined the signals as C. In fact, you define them as C0, C1, and C3. I think it should be C0, C1, and C2. And then on line 18, the C in connection should go to C1, not C2.
Oh, gotcha.
Right, that's a little better. And now on the signal line on line 15, change the name of C3 to C2. Okay, try that. I don't know whether that's going to help. I'm hoping it does a little bit. Positional associate. Okay, I'm going to have to Google it. I was trying to get away without Googling it. So what does it say? Positional associations. Must be listed before named associations. Line 17, begin. Let me just check my code because it doesn't look too different from what I have. In fact, it looks almost exactly the same as what I have. Ah, la la la. Component full adder A, B, C in, student logic S, comma, C out. End component, that looks good. I've got adder 3, full adder, port map, A goes to A and 3. That's exactly what I have.
I mean, does the capitalization of the C matters? If
No,
that's-
it should be case insensitive. So somebody is playing me in the background on video. Would you mind muting if you're doing that, please? I can't see what the problem is with this way. It looks okay. I don't quite know what that error.
If I could just chime in really quick, I think it's his lab name. It's actually not calling the 4-bit adder. It's actually just lab 4. I don't know if that has anything to do with it.
Ah.
How would I change the name?
Oh, I see. Yeah, so this is called... You've got lab 4 and you've got full adder. Okay, that's all right. Yeah, so maybe that's the problem. So go into that Project Navigator window and right-click on Lab 04. The Project Navigator window below that, where it says Cyclone IV. Right-click on that. Go to Settings or Properties maybe. Yeah, I can't see the Properties window. So right-click on. Did the Properties window come up?
Properties.
Yeah, I can't see
you guys can't see it?
No.
You might be able to click the share your screen again and then click on the separate window.
Change window.
Yeah, but I think you might be right, Harvey, that the issue is to do with the naming of the top level entity.
But then now I can only see the property.
Most likely, but he needs to see the window.
Yeah, instance name, go to File Properties. Yeah, no, close that out. It might be Settings. Ooh, that's a really really
tiny window.
Indeed. Okay, so yeah, right click on the Cyclone IV eAuto and go to settings, and there should be a line in the settings called let me just do it here so I can see what's happening. There should be a line there. If you go to the General tab, there should be a thing that says top level entity. Make sure that says 4-bit adder instead of lab 4.
I can just change it without. Oh, okay. 4-bit.
Okay, so save that, and there we go. So now it's got the right name in there. See what happens when you compile that.
It's a Okay, let me see.
Positional associations.
It still says Lab 04 right here. Does that matter?
It shouldn't matter. It's just that's just the file name. Yeah, double click on that. Let's have a look. I think that what that's meaning is hold it.
Does it have anything to do with the setting again? Because I reinstall Cortez because I don't know why last week Cortez wouldn't respond to opening up a new project, so I had to reinstall it.
Okay.
I'm not sure.
That shouldn't matter. There might be some other things we need to do in order to generate the test bench and that sort of thing, but it should still compile, and I'm very confused as to why this is not compiling. What I think that positional associations must be listed before named associations means is that the port map that you've got there is swapping things around. So instead of the inputs are on one side and the outputs on the other, it's the wrong way round. But it doesn't look like that's the case.
Yeah, because it's only on line 17 and it doesn't apply to 18, 19, 20.
Okay, so let's try this. Just put 2 minus signs at the beginning of line 17 and try compiling again. Yeah, try. So that's just commenting it out, and let's see if it gives us the same error on the next line. Yeah, so it's now so it's just barfing on that. So there's something wrong with all of those lines. Okay, try, see where you've only got B3, B2, B1 and B0? Try doing a map from B equals greater than to B3. Just the one line, just that one there. On the other side, B equals greater than B3. Right, because all of the others have mappings, that one doesn't. So you need you need a B in front of the 3. So see where it says after the equals greater than sign, there should be a space, and then there should be a capital B. Yeah, put a capital B there. That's it. Now try compiling it. If it gives an error on line 18 rather than line 17, we know what the problem is.
Object B is used, but not declared.
Oh, it's called...
Oh, B3 is not declared yet.
It's B in. That's what the problem is. B3 should be B in 3. B2
Yes,
should be B in 2. B1 should be B in 1.
Oh.
Yeah, that's what... Sorry, I should have seen that. Okay. Try that and see if that compiles and you get an error on the next line. And
actually, I still think...
Line 18.
Yeah, so now it's line 18. So you need to change all those to be in, because that's what it's called in the port definition up the top there.
Yeah, it should fix it.
Yeah, okay. So what I said was correct. I just couldn't see it. That's what that...
Yeah.
Okay, see what that does.
Ooh.
Now what have we got?
Oh
Can't
my
type
goodness.
logic.
Oh.
Logif.
Yeah.
Okay, so yeah, see line 5 there, you've got a logiv instead of a logic. Yeah, try that.
Oh my god. One after the other.
So let's have a look at that. Right, so you've got you're assigning C out twice. You don't want to do that.
Oh, yeah.
Yeah, that first one could be removed.
Yeah, just remove it. And I don't know whether that second one is correct, but that's...
It should be. Woo.
Okay, it's compiling. Woohoo! Okay, who's next?
That'd be me, Anthony. I'm actually getting the problem that happens exactly after this. After you get everything set up, I can't get into the test bench because I do not have executables leading to the Altera.
Okay,
I can.
so
I
you
can
want
post the.
so what you've got to do is you got to go Tools, Options,
Yep.
EDA Tool Options, and then
Yep.
browse to Model Sim Altera, and it's got called Model Sim _ ASE Win32 ALOEM. And this part will probably be a bit different, or maybe a bit different from your installation, but once you're in the...
Yeah. So I get to the test module, but I don't see the actual files that you're referring to.
Can you share your screen so I can have a look?
Yeah. Yeah.
Where are we?
So this is the.
Hold it. Let me just...
This is after I've gotten into the directory for Model Sim Altera. This is what it brings me to.
Right, so what you got to do is you got to go to your C directory. So go to this PC and C, and this is your machine, is it? There you go. Intel
Yeah.
FPGA Lite 20.1 quarters. Oh, sorry, Model Sim ASE, sorry. And then down the bottom is Win32 blah 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 ALOEM. And that's it. Select folder. Oop. Your screen just closed. So that...
It's because the window closed after I clicked that.
Oh, I see. Right. So that should get you... that should set you up for the right Model Sim Altera path in that options, EDA tool options window.
Oh, yeah. I
and-
believe it's starting up right now.
And now you should be able to generate. Just make sure you're generating VHDL rather than Verilog. And the way to do that, if I can remember, is settings, I think. And yeah, so this is on the EDA tool settings simulation. We've got Model Sim Altera selected, and the format for output netlist should be VHDL. And if all of that's hunky-dory, then it should, when you do whatever it was, processing start, and I'm not going to do it because it'll blow away my test bench, start test bench template writer, that'll, the one down the bottom, the second from the bottom there, that'll generate the test bench. Okay?
Yeah, thank you.
You're welcome. So, let's see who's next. Quentin.
Hi.
Ah.
I had one issue, but then found a second one. So I'll start with something in Quartus. Let me
Okay.
share my screen.
Mm-hmm.
This happens a lot when 'cause I'm doing it through the virtual machine, and this happens a lot every time. Like usually like the next day, like I have a project and then I go back to it the next day, and it's like I have to restart the whole project because some sort of compiling error. The Quartus Prime software quit unexpectedly. I don't know if this was ever discussed, but it I can't seem to get any information other than that thing that pops up. So, can you see my screen?
For some reason my window went away, but now it's back.
Okay.
I see. Sorry, I've got too many machines happening in too many things. Let me just move that over to the other screen. Okay, so what do you got?
Okay, so when I compile my stuff, it's strange because before class I got to work, and then as class went by, 3 hours goes by and it boots me off, and then when I boot back up, I try to reopen my same project that I just got to work, and this happens usually at 90%.
Are you saving this at oh, that's sucky.
I did it on both. I tried it on like the C drive on the machine, but then I also it should be on the OneDrive on my account.
Yeah, so what's probably happened is when the machine boots you out after the 3 hours, what's probably happened is it's left some files in a bad state. So what you need to do is, I think,
Isn't there a folder that is mine that I can like put all my files in that wouldn't corrupt it?
well,
Isn't the one right
well,
here?
the OneDrive is still your OneDrive, but the thing is, you're running Quartus, right? And it's it's accessing those files, and then the virtual machine blows away the instance of Quartus that's accessing those files, and that means that it's possible that those files are corrupted.
Yeah, the subsystem file Quartus. This seems to happen. Where should I save the file where this one happened, or am I gonna have to like restart the project?
Well, that's what I'm saying. So,
Did you try cleaning your projects? I had the
That-
same issue.
that-
Oh,
that's
right. There was that.
right. That's where I was going. Right. Try going project clean project, because if there's some in any IDE, VHDL or C# or anything, if I find what I think is bogus behavior, I just go and clean the project and recompile, just in case there's some dodgy intermediate file
Do I
there.
need more revisions or
I usually blow away everything, all revisions, because it's not as if you're making a huge design and you want to keep some of the revisions. It's a small project, so just blow everything away.
Okay, so that cleaned it. Let's see if that worked. I remember you mentioned something about clean, and right when whoever said that, I'm like, oh yeah, that's right. Let's see if this did anything.
It looks happy enough, doesn't it?
Yeah, it's usually at 19% it crashes, so whatever was stopping it seemed to fix it.
And what's happening is when that machine goes away, even though it's
Like it like wipes it, so that file that needs to open the project is deleted or something.
well, it might just have what I suspect is that there's some sort of a lock file there, and it's not expecting that lock file to be there from a previous instance. And just running that clean will clean up the log file and do the right thing.
All right, I'll keep that in mind because that worked. That was the first one, but then my main question was related to the multi-sim.
Okay.
So you wanted a multi-sim. I was able to do the 4-bit adder here. You said you wanted to have test points or something other than just like the picture of it. You wanted us to do something with it.
Right. So and just like the VHDL, I don't want you to do an exhaustive test, but just put in, I don't know, 8, 10, 12, some number like that of tests where you show the inputs and you show the outputs and you think the outputs are correct.
Okay, I got it.
Okay.
So I put switches, so I can just like screenshot like
just
different variation that I have.
Yeah, exactly. So I would suggest just to make it easy, several different values and do add and subtract on those different values, and then you're pretty much done, right? That shouldn't take too long. Just screenshot it all. Okay.
All right, thanks.
You're welcome. Okay, let's go back to there. And who's next? And Jacob's next.
Hey, Professor.
So, what's up, Jacob?
Here, I'll share my screen real quick. The question I have is my 4-bit adder code for the 4 different adders is different than how everyone else is, so I'm not sure if I should change it to how it is or how it is now. It's fine.
Okay, so I'm not quite sure I understood exactly what you're doing, but tell me.
As for over here in this section, everyone has it different than how they have it for their adders, so I'm not sure if the code how I have it now is fine or if I should change it to how it was with everybody else's.
Okay, so this.
Because I followed your lecture, and that's where I ended up being, and it compiles fine and it simulates fine. I'm just not sure if it should be changed or if it's fine how it is.
Well, the one issue I think is you've only got 2 full adders, right?
And yeah, in a sense.
The logic diagram on the lab statement has four full adders.
Gotcha.
Right. So, what I can see there looks okay, right? You're forming x0 and x1, which is the exclusive OR of the b's with the subtract bit. That's correct. And then you're using x0 and x1 as the inputs, the b inputs on your full adders. That's correct. You're putting subtract into the carry in on the first full adder. That's correct. The bit that's missing, and then you're connecting the carry out of the first full adder into the carry in of the next full adder. That's correct. But I don't see FA2 and FA3. Right?
Okay, so that I just have to add the other 2 adders. All right, that makes sense.
Yeah, and then you'll can remove the S2, S1, and C out down the bottom. Okay.
All right, makes more sense. Thank you so much.
You're welcome. And I don't know whether. Okay, Mohammed, you're up. What can I help you with?
Okay, so it's basically the same thing as Jacob. I know what to do now, but every time I try to simulate what I have, it says I can't find the design file. Let me see if I can share my screen.
Yeah, maybe share it so I can have a look.
Can you see it?
It's coming. Yep, I can see it.
Okay. I go here, try to simulate. and nothing's happening. And it says error loading design.
Where's it saying you've got another window? Is there? There's a.
Oh, am I showing the wrong window?
Yeah, I can see Quartus. I can't see the model sim.
Okay. Okay, I got it.
Right. So I'm not sure why this happens, but sometimes going from Quartus to model sim causes this. So what I suggest you do is where you can see the full bit adder subtractor VHD test is highlighted. Also select the other two under the work directory there. So select all three of those entries. Right, and now right click on it and select compile. Okay, so there's no errors. There's some handoff between Quartus and Multisim that gets in the way, but if you recompile, that should be all okay. Now select the VHD test, the middle entity in that work, and go right click and simulate. And that should fire up the simulation. Ooh.
Yeah, I tried doing that and nothing's happening.
Did it got another error? Did it? Can you just
error keeps popping up.
Can you just open up that bottom window a little bit more so I can read more of the error stuff?
Just did.
Yeah. So just move that over to the right, the divider over to the left a bit, so it's a bit more readable. Okay, fatal error. Full adder, line 6. Full adder is not in the component being instantiated. Okay, can you take me back to, ooh, there should be a full adder there. It seems to be, it's there. Port A of entity full adder is not in the component being instantiated. Port A. Can you go back to Quartus and open up your test bench, please? So you just scroll up a little bit more. Yeah, there you go. See, your full adder names are A_FA, B_FA, etc. So just scroll down a little bit more.
Yeah, I've been following what you posted for last week's lecture. Thanks, stuff like that.
Let me just have a look at my my full bit adder VHT. Oh, that's the have you got? You see, I can't see any port maps. Right, so you've got the component up there at the top that ends on line 83, but what you need in your in either your init or your always process is an instantiation of the device. right? Let me just. Oh no, that's unit under test full adder. That's correct. That should be the initiation. Oh, that the instance. Can you just scroll up a little bit more? Yeah. Okay. So there we go. So we've got two of them. We've got. Okay. So the example I was doing last time, I was actually double dipping, right? Normally the test bench only works on one unit under test. So what I'd suggest is just remove the full adder unit under test. So just remove that code. All right, just comment all of that stuff out. Down to line 83. Yeah, so okay, now let's see what that is saying.
Should I compile it?
Not just yet. Let's just see how that goes. Ooh. There we go. Oh,
I'm sorry.
yeah, it's just a bit. So there you've got your 4-bit adder. And you've got A to A and B to B and S to S. That all looks okay. Actually, can you just open up the 4-bit adder subtractor.vhd file? Okay, so there's, I think, a problem. See the port statement that starts on line 22? You've got your, it's a full adder. Actually, can you just scroll up to the, right, so here you've got A, B, subtract, S, and C out. Have a look, see that you've got first of all, you've got the 3 inputs and then you've got the 2 outputs. Have a look at the VHT file and see you've got, I don't know whether having the connections in a different order here is going to matter, but I suggest you swap lines 72 and 74 to get...
Just switch them?
Sorry?
Just switch them?
Yeah, just switch them in the VHT for Tommy file. Yeah, because that way you'll have all the 3 the 3 inputs and the 2 outputs together. And you'll need a comma at the end of that.
Okay.
Not that one, you don't need a comma there, you do need a comma at the end of the subtract line. And remove the C as well. Yeah, okay. So see if that compiles.
What, are they the same? Did I mess up?
Oh, sorry. The line 74 should say I've forgotten what it is. It's C out, isn't it? So it should say C out.
Yeah.
C out maps to C out. Yeah, like that.
Right.
Yeah, I think so. Let's just go back to the 4-bit adder subtractor and just to check to see that that's... Yeah, so A, B, subtract, S, and C out. That looks correct now. So save that VHT file. It'll save it if you compile it, but just Control S. Let's see how that compiles. Hopefully it'll compile. I'm a little concerned about the error though. I haven't explicitly seen why that error was there. The model sim error.
Yeah, I was confused too.
While that's compiling, can you just take me back to the model sim window,
Yeah.
and so we can see the error?
Can you see it?
Yeah, I can see that now. Thank you. Fatal. Port A of entity full adder is not in the component being instantiated. Okay, so we're now not instantiating the full adder because we've taken it out. Okay, can you see where it says fatal vsim 3817? Double click on that error line. It's not going to take you there. Try.
Oh, it's
No.
not doing anything.
Okay, that's all right. So I'm going to have to ask you to take me back to Quartus and have a look at the VHT file again. Oh, okay. So see where you've got the component full adder? You can take that out. We don't need to, if we're only testing the 4-bit adder subtractor, we don't need either the unit under test full adder or the component full adder. We only need the 4-bit adder subtractor.
So take this part out?
Take that part out and the part from line 65 to 57.
65, 57. Okay.
Okay, can you just scroll up a bit more? Okay, so we probably don't need lines 42 through 46. Okay. And there's the port A, B, C out. Oh, hold it. Can you just go to the 4-bit adder subtractor.vhd file? AB subtract SC out. So yeah, go back to the VHT file. You need to get those in the same order, right? So the where's it gone? Yeah, that one. So line 48 and line 50 need to be swapped. Get the inputs and the outputs in the right order. Okay, now, yeah, that one. Okay, save that. A, B. That looks alright. We've got signals A, B, 4-bit adder. Just scroll down a bit so we can have a look at the rest. That looks okay. There's instantiating the 4-bit adder subtractor. That looks good. And that's setting A and B and subtract. That all looks good. We get S and we get... Okay, I think that's okay. So let's just compile this here now and see that that works. Okay, that looks happy enough. So now let's go back to basically all I've done is I've taken out some of the stuff that really wasn't needed.
Okay.
I don't think I've fixed the problem yet, but having that other stuff in there might have confused the issue, at least for me understanding it. So let's go back to model sim. Okay, so just select all three of those things under work and recompile. Okay, now just select the VHD test bench and say simulate.
That's working now.
It's working? Okay. Yeah, that looks a bit better, doesn't it? Okay, so you should be okay as far as the getting the simulation to run now is concerned. Okay?
Yeah. Okay. That helps.
Right, so now the thing to do is to select, in that objects window, select A, B, C out, S and subtract, and then right click on the selections and say add to wave selected signals, and that'll generate the wave, the timing diagram.
It won't let me say add wave 2.
Sorry?
Oh, add 2. No, never mind. Never mind.
Yeah, so it's usually like that, and then add to wave selected signals. Yep, and now you should be able to, I usually change the timing from picoseconds to nanoseconds just because it's, so see where it says, yeah, that's right. And now just hit the icon to the right of that box, the page with the down arrow on it, and that'll that should simulate it. Okay, try it again. Okay, now in that wave window, type capital F, and it should show you all of the
Type capital F.
Capital F for full zoom. Right, and now you can see all of the simulations. You've changed the two inputs from 0 to 1, and the output changed from 0 to 1, 0. Okay, so that looks like it's doing the right thing. If you go back to the other, where is it? It's probably the window over on the far left with the output. That one's probably got if there are any assert problems. Not that one, the one beside it, which is, yeah, there you go. So scroll down to the bottom of that far left window and see what the run statements say. So there's no asserts coming out there. So the tests that are there in your code have passed, it'll only output an assert if the condition on the assert is false. And the only asserts I saw in your code were failures. So if there was a problem with the output, so that means there's no problem with these outputs. Okay. That all looks good.
All right. Thank you so much.
You're welcome. Okay, let's see who's next, and I'm going to go shortly. So, but I think we got Jacob first. So, Jacob, do you want to?
Yeah, it's me again.
Okay, what's wrong, Jacob?
I tried to simulate because I added the other adders, and when I try to simulate, I also get a loading design error.
Okay, so see where it says work in the about the middle of the screen.
Yeah.
Select
Should
those.
I try to?
Yeah, select those 3 items and right-click and recompile.
Oh, okay.
And
Never mind
now
then.
select the test bench and simulate. And you looks like it's good. Select all of those. Add to wave selected signals. And that'll generate that bit. And then you can maybe change the time step to 100 nanoseconds. And click the one beside it and see what happens. Yeah, click it again maybe. Okay, now type capital F and that'll zoom out or in. Yeah, there you go. So
Okay. What'd I do?
oh,
no, hold
it's got a
yeah. I wrote a capital F into name.
Yeah, not sorry about that. Yeah. So yeah, capital F down here, and that should zoom out to the full, right? And there's only 2 different values, which looks like it's the same ones that Mohammed had. Okay.
I also have another quick question, because I'm not sure if I'm missing a VHDL that should be for just 4-bit by itself.
Sorry, say that again. I don't understand the question.
Because I have a adder and subtractor and a full adder, but I'm not sure if there should be another VHDL for this lab, if I'm missing one or not.
The only 3 files you really need are the full adder, the 4-bit adder subtractor,
yep,
and the test bench.
Gotcha. All right.
Yeah, it looks like they're all there, right? We just ran the test bench.
Yeah.
If the test bench passed, then it looks like you've got a full adder. So I think you're good.
Alrighty.
Okay.
All right. Thank you so much.
You're welcome. Bye bye. And I think we got at least Javier there. So let me just see who's next. Okay, Javier, you're up. Hello? Are you a bit quiet there?
Yeah, oh, I'm sorry about that.
That's okay. There you are.
So, I am honestly just having trouble with the test bench.
Okay. What trouble do you have with the test bench?
It's not generating.
Okay, let's have a look. Let's have a look at quarters.
Yeah, okay. Alright, do you see my screen now?
I can see your screen.
Perfect.
So let's just make that biggest. So you want to go to Tools, Options, EDA Tool Options. You've got that set up, and that looks like it's the right one. Yep. Okay. So then processing start. Now can you just scroll across? Select a valid simulation tool. So right click on Cyclone 4 E up in the top left there. Go to Settings. Go to EDA Tool Settings Simulation. Select Models in Altera. Select VHDL where it says Format for Output Netlist. And hit Apply. And OK. And now try processing start. Okay, now it's actually generated a VH. You're welcome. So now it's just a blank one. It doesn't do anything. You're going to have to fill out, well, it should have the unit under test. It should have the 4-bit adder, but you're going to have to tell it. Yeah, so it's going to be under simulation, model sim, and then the VHT file. Yeah, that one. Okay, so usually the always after the beginning, the always there. That's where you put your tests in. Yeah, down there, right at the bottom. So where it says code executes every event in the sensitivity list, that's where you put your test bench in.
Okay, awesome. Thank you so much. Sorry about. I know you probably explained that 1,000 times as I was watching the video, but I was just having the worst time trying to figure it out.
That's okay. I've done it a few times now, so it certainly really is confusing. I spent quite a bit of the summer getting myself back up to speed with Quartus because I remembered last time I taught this back in 2018, it confused me. Thankfully, this version of Quartus is actually quite a bit better than the previous version, so it's less confusing than it was, but it's still confusing.
That's really hard to believe.
It was not pretty. Well, the one that I remember that was just ridiculously confusing is in Quartus, where you do tools, options, EDA tool options. This one here, it would the installation would automatically fill it in incorrectly.
Oh no!
It would fill it in exactly like it is, but the program wouldn't work.
Oh, interesting. Okay.
You had to put a trailing slash on there for in the path in order for the thing to work, right? And it was just so annoying. But anyway.
I'm glad they patched that out.
Yeah, exactly.
All right, thank you so much. I'm going to watch the video for the rest of the test.
No worries. Yeah, so if you got VT instead of VHT, that means that the where is it? So it's in tools, options. Oops. No, sorry, it's in the settings page. So what that means is over in the settings on the project, it means that you didn't set format for output netlist to be VHDL. You set it for, which is the default. It was set to Verilog HDL. You got to set it to VHDL in order to generate the test bench for a VHDL test bench. Okay. And I think I'm out of time. So thank you everyone for your attention, and for those of you who stayed around. I'm going to stop the stream and stop the recording, and we'll leave it there.